Okay, day 4, and I hope you guys have watched the previous session's recording as well. Yeah. Okay. So the ones who are here today, did you guys attempt the paper I sent? So even though it is a grade 12 final term paper, this is targeting mainly for the 2026 A level. To recap their grade 12 syllabus, some might be like, how can you recap using this 40 MCQs? We will see that. I'll show you how. Right? So let me know if you attempted the paper. Just yes or no, drop in the chat box quickly. And this session would go a bit faster, but still, if you have any doubts or if you want me to explain any question again, you can let me know that. After all, you all should be able to understand it, right? So no use of me going in a speed. Okay? So no one attempted the paper. Is that so? Just let me know yes or no, so I can know that. At least went through it, went through the questions. If you didn't attempt it fully, only the MCQs. So today I'll be discussing only the MCQs. If we have more time, we will be discussing the structured part as well. Essay discussion, I will check another day. Right? No. Anyone else? Did anyone attempt the paper? Okay, it's okay. I think I know there are classes and all, so it's okay then. If you haven't attempted it, at least do it with me. So you can drop the answers in the chat box, right? Okay, so let's begin. I think it's enough of waiting. Many are having classes and all, so yeah, they are unable to join, even the usual ones. Okay, it's okay. Let's begin. Yes. Okay, so this is an FWC last year's grade 12 final term paper. So simply it's the 2026 paper, actual 26 A levels. If you were in a government school, if you're in a government school, they would have given you this paper maybe to do, right? So for ICT, I would recommend to do Mora papers, but since we are doing grade 12, I just chose to do FWC. Because you could see it has a different type of question as well as some questions might not make sense. It's okay. After all, it's about recapping the syllabus, right? So let's see how will I do that. Right? Okay. Yes. Okay. Okay, so the first question, which of the following statements about computer software is correct? Now, when students go through this question, they will automatically get the answer, not by reading. But how do you think? By seeing the sentence which has the large amount of words, and that is the fifth option. So yes, in some cases, the options which have like this, a large amount of words, which is larger than others, Definitely yes, not definitely. I mean, sometimes yes, that could be the answer, but sometimes no, it could be a trap. Who knows, right? So let's go one by one since this is of unit 1. I'm not going to go in depth. I'm in unit 5 also. Okay. So Ubuntu Linux is an example of proprietary software. Yes or no? So you know that there are two types of software. Yes, free and open source, and not proprietary. What have you got? One. No. Can anyone else try and say? Let's see. I am getting some different answers. I'll wait until then. I'll just check on this. I'll send the link, YouTube link can come. Until then, just drop this answer. Let's see. Because I think students might get wrong in this question, right? Some. Okay, so actually, all of the answers you guys sent are wrong. No one sent the correct answer. Others, just give a try. After all, it's a matter of trying since you know you have only few days left. I would say, even though it's 2 months, it's like few days, right? So after all, now it is the time to do lots of papers, not theory recaps, and that is why I started this free paper series. Okay, and as I mentioned, nearing to your exams, the number of amount of sessions would be increasing a bit, and I'll be focusing maybe on full papers or either a chapter which is a highly tested chapter. Yes. So anyone else? Okay, great. I got only one correct answer. So you know there are two types of software, proprietary and open source and free. So proprietary, it's like it's owned by an individual or a company and the source code is hidden. Whereas open source and free is opposite. Anyone can download, modify and distribute its source code. Yes. So Ubuntu Linux is an example of a proprietary system. No, it is a popular. So Ubuntu is a popular Linux distribution that is completely open source and free, right? So that's not the answer. And then an operating system is an example of application software. You know that there are two types of system software. So what is the system software? Which manages and control the hardware. Yes. So computer software is divided into two primary types, system software and application software. So system software is something which manages and control the hardware, whereas application software is which helps users perform specific tasks like writing documents or browsing the web and all. Yes. And under system software, only operating system comes, not under application software. So example for application software is like MS Word, MS Excel, everything is there, right? Those apps. Okay. Okay, so I hope that was clear. So don't forget that there are two types of computer software. There is divided into two types: system software and application software. Operating system comes under system software. Okay. And then Microsoft Windows is an operating system that must reside compulsorily in all computers. Is that so? No, right? While Microsoft Windows, it holds a large market share, it is widely used everywhere, but it is absolutely not compulsory at all. Okay, it's not compulsory. A computer can operate using alternative operating systems. Example, how Linux, Unix, Mac OS, and all, right? So some specialized computers run custom embedded software also without traditional desktop operating system. So that is also false, since they mentioned compulsorily also. Okay, Microsoft Office is an example of a system software. What did I say? Yes? Oh no, no. It is an example of what then? Microsoft Office in a sense, MS Word, MS Excel, MS PowerPoint. These are designed directly for end user, right? For the end users. So it does not manage the computer hardware, which is managing computer hardware is a function of the system software. Yes. So this is coming under the application software. Okay. Yes, application software. Great. So yes, the answer is the fifth one. Okay, so just check out the ones who got wrong, check why you went wrong, and please correct yourself. I hope you understood now, right? Why the other options are wrong, and you got a bit recap on what is an operating system. Sorry, operating system, application software, and system software, right? So let's see the fifth one. Only application software compatible with the version of the OS can be installed on the computer. So, applications are built using specific instructions, which is provided by a particular operating system, right? So the relevant apps should be compatible with the version of the operating system, right? So, like example, now iPhone 5 and all, it doesn't have WhatsApp now. Some in most of the iPhones, you cannot use WhatsApp. Old iPhones, I mean, yes. Okay. So I hope this was clear, and the ones who went wrong, just check it out a bit. Okay, let me just highlight the answer. All right. Okay. Consider the following statements about the post power on self-test process. Okay. Statement A. So this is saying this is done by the BIOS program. Yes or no? Is post done by the BIOS or yes? Good. Yes, so the BIOS basic input output system is firmware stored on a flash memory chip on where? On the motherboard. So when you hit the power button, the CPU looks at the BIOS first, and then the BIOS automatically initiate the post routine before any other software can load. So yes, that is true. Okay, and then they saying operating system does this. No, operating system is stored on a storage device like storage drive, like an SSD or an hard disk drive. So the computer cannot access the storage drive until the hardware interface is verified, and the post happens at the hardware initialization before the operating system loader is ever read into memory. Okay, so that is done by the BIOS program. So see, during this process, main components like CPU, motherboard, main memory, hard disk, ROM, and video graphic cards are checked. This is true or false? Yes. Let me just check your messages. True, true, good. If I missed out any doubts, you can just note and keep it. True, true, true. By that operating system is loaded. Yeah, yeah. True. True. Yes, this is true. Why? The purpose of post is to what? To check, right? So it sends the electrical signals to verify that the CPU is responsive, that the RAM chips can read or write data, the graphic cards can output a signal, and the storage buses are connected. So if any critical check fails, the motherboard emits an error code, like it beeps or it displays an error code, right? Halting the booting process to prevent hardware damage. So yes, that is also true. So they are asking which of the above is are correct. So it is option 4, A and C. Alright. Okay, I hope that was clear about post. This is an highly tested area, I would say. So just focus on that a bit. If you don't know, you can you might have theory notes and all, right? So refer to that. Okay. So consider following statements about cache memory. So okay, this is used to store frequently used instructions. True, right? So this is very easy. Everyone knows that it stores frequently used instructions. So the CPU, it operates at what extremely high speed, while the main memory, which is RAM, is relatively slow, right? So to prevent the CPU from waiting for data, the cache memory acts as a high speed buffer that holds the exact instructions the CPU is predicted to need next, right? I hope that was clear. So that is true. Okay. This memory is very cost effective compared to main memory. This is false. This is made from what static RAM, which requires complex, circuitry, like it requires like resistors and all per bit. But main memory, it uses dynamic RAM, which uses a simple transistor capacitor pair, right? So because of this architectural complexity, SRAM chip space is massively more expensive than DRAM. Okay, I hope that was clear. So remember, it only main memory uses DRAM, whereas cache memory uses static RAM, which requires complex circuitry. So this is false because it is not cost effective comparing to main memory. Okay. So see, this memory is in more storage capacity than the main memory, right? This is false because of its extreme cost and the physical space it occupies directly on or next to the computer. The size is strictly limited, right? So it is usually measured in megabytes. Okay. Whereas RAM is measured in what? GBs, gigabytes. Okay. So it is not more, it has less storage capacity than main memory. So that is false. Then statement D, this memory is available in three levels such as L1, L2 and L3. Yes, you know it has three levels, right? So L1, it is what? Fastest, smallest capacity, and it is built directly inside the CPU core, right? Whereas L2 is slightly larger than L1, but it is slower. So the fastest is L1, okay? Comparatively out of all three, L1 is the fastest. Whereas L2 is slightly larger, but it is slower than L1, right? And L3, this one has the largest capacity and it is slower than L1 and 2, but still it is faster than RAM, okay? And this one is shared across all CPU cores. Whereas L2 is dedicated to each or shared among, okay? So yes, that is true. It has three types and focus on that a bit. Study the three levels a bit. They could, test as an MCQ as well. So the question is what? They are asking which is correct or false. Incorrect. False. Right? So option A is correct, B is false, C is false. Right? So answer is 3. B, C, D. So be careful. Sometimes you might, in a rush, if you're in a panic mood, you might go and mark the correct ones. Right? Okay. I hope I'm not going fast. This is speed okay for you guys? Just let me know that if this speed okay, if you want me to go a bit slower. This is perfect. Oh, great. Nice to hear that. Okay. Yes. So I want you guys to just try this question. So some questions I'll give you time to try, some I will just keep on explaining. Okay. Just try this. This is easy, no? Just I want you to try it. So some questions, if I'm giving you to try, that means you need to focus that on a bit likewise. And see, they are asking respectively. Okay, so be careful on that. Very easy actually. This one is an easy question. If you know the diagram. Nethuli, yes, correct. Good. It's easy, no? Yes. So this is like representing the von Neumann architecture, no? It divides into what? Input, process, which is CPU, memory, storage, and output. So the first component is input device, right? So the arrow is pointing to the central system. So input devices like what? Keyboards and all, right? They send raw data into the computer for processing. So input, and then next one should be what then? Processing, which is what? The central processing unit, the CPU, right? Because why? The input devices send raw data into the computer for processing. Okay. Okay, so C then component 2, which is CPU. This is the hub of the computer. It receives what? It receives input, interacts directly with the storage, and then routes the final results to output devices. So the arrow is also going like that, right? So that's what the CPU does. Third one is storage. Okay, and see the two-way arrows. This is indicating a bidirectional flow of data. So the CPU reads data or programs from the storage unit, like loading a file, like guys, and then writes data back to it, saving a file. So loading a file and then saving a file. So that's why it's showing two arrows. Okay, from CPU to storage or secondary memory, you could say it as. So then the answer is option number 2. Going to explain this in depth, right? I hope you already know this architecture, right? Okay. Okay, so this is about the CPU registers. Okay. Registers are the fastest access memory locations in the CPU. Dash saves the result of the ALU, right, of calculations performed, and then the dash contains the memory location for the next instruction to be processed, and then dash contains information such as where to get the data it needs to fetch or where to store the data. Okay, so this is speaking about the fetch, execute, decode cycle. Yes, yes, am I right? It is showing the fetch, execute, decode cycle. Yes, we know in that there are registers used, different types of registers and all, right? So what registers are? What they are, like ultra fast, small capacity storage locations built directly inside the where CPUs. They hold what the data that needs to be processed, so that the processor needs immediately while executing an instruction. Okay, they hold data that the processor needs immediately while executing an instruction. So A, what are they saying? It saves the result of the arithmetic and logical unit of the calculations performed. This is the job of the what? The the accumulator, right? So when the arithmetic logic unit adds two numbers, the temporary sum is dropped straight into the accumulator. Okay, so that is accumulator. Then the blank B, it is saying what contains the memory location for the next instruction, right? And this is very easy, you know. This is the definition of what program counter. It keeps track of the line of code which is currently being executed and increments itself to the to point to the address of the next sequential instruction, right? What does program counter does? It keeps track of the line of code which is currently being executed and increments itself to why? To point to the address of the next instruction, next sequential instruction, you could say it as. So that is program counter. Then blank C is saying it contains information such as where to get the data it's need to fetch or where to store the data. So once the instruction is fetched from from memory, it is copied into the instruction register, right? Sometimes you call that as the current instruction register, but we call it mainly as the instruction register. Okay. So the IR, it holds the, instruction register holds the instruction code, so the control unit can decode it and find the address of the required data. Clear? It holds the instruction code, so the control unit can decode it and find the address of the required data. So it contains information such as where to get the data it needs to fetch and where to store the data. So then the answer is option number 3. Sorry. All right. I hope that was clear. Okay. So next is about unit 2. Data validation. So, you know, on your data validation types, they give you a scenario and ask, right? They give you a scenario and then they give you statements and ask which is suitable, and you have to be careful on that. Some students go wrong on this, even though it's very easy. Okay, so students' personal information and their exam result marks are entered into student information system. So marks for a subject between ranges 0 and 100. And a student has to study a combination of compulsory as well as optional subjects and appear for the relevant examination. So which of the following is the suitable data validation they ask? A presence check for marks in all the subjects set or not set by the student. This is incorrect. Why? Because a present check forces a field to not be blank, yeah, right? You cannot leave it blank. So if a student did not sit for an exam, forcing the system to to require a mark entry is incorrect, right? So the field should be the field should either be left blank or flag an absent status, right? So this is false. Because it is only being, you cannot leave it blank, but in this scenario, this is not suitable, right? And then statement B, a range check to check that an input examination marks is in a range between 0 and 100. Yes, since they have mentioned that marks for a subject ranges between 0 and 100, you need a range check to check if it is between that, right? So the exam percentage, it cannot fall below, it cannot fall below 0% or above 100%. So range check ensures that typos are instantly blocked. Okay, and then statement C, a data type check to ensure that the input carried out for the student's phone number contains only the digits. This is true because phone numbers must strictly consists of numeric values. A data type checks prevents a user from accidentally typing letters like A, B, C, D or symbol into a purely numeric database field, right? So the answer is which of the following is most suitable, right? It is B and C. Okay, I hope it was clear. Okay, so this is another important topic, that is the memory hierarchy and access speed. So they are saying which of the following memory groups represent the access speed from left to right in the ascending order, right? So it's fastest to slowest. Okay. Let's see the first option. So this is this is in the opposite order, right? It's going in a descending order, right? So you know hard disk, they are the slowest. So if they are saying from left to right means the speed should be what? Increasing, right? So it is like hard disk to main memory to cache memory to register, right? And a main memory, it is faster than hard disk because of the magnitude and all, right? I'm not going to explain this in depth, right? And then the cache memory, it is built closer to or inside the CPU chip, so it offers a bit faster access than others, than main memory and hard disk. And register, since it is sitting directly inside the internal processor stage inside the CPU, right? It operates at the exact speed of the CPU clock cycle. So it is always the fastest, right? But capacity wise, it will go opposite. Register is smallest. So CPU register is on the CPU core. The cache memory is high speed RAM near the core, whereas main memory is, I said about the DRAM system. And hard disk, which is secondary storage, is, but capacity wise, hard disk has the largest capacity. Okay, so the answer is this, since they are saying about increasing the speed from slow to fastest. If they mention descending, the option would be first. Sorry, not first. Okay. Okay, so then they are saying which of the following is are equivalent to the binary number given, right? So they are given more than 8 bits. Okay, can you convert this and say, convert and say, in decimal value, how much is it? Can you do that? So this is in 1, 2, let's see, I'll also do. Don't worry, in your exam, they won't give more than 8 bits. They haven't given like that usually. Have you got the answer? Do this, then only if you do something, you will be active a bit. If not, you will be bored. So it's like this. So this is in 2 to the power 1. So it's like 1 plus 2 plus 4. So not 1. 2 plus 4 plus 8. And then it is in 128. Okay. And then it is 256. No, 512. I'm adding that. And then again, there's another 0. That is, okay. That is in 2 to the power 10 position. 2 to the power 11 is 2048. So you're getting a value, right? You will get the decimal value as, sorry, okay, sorry for that. So in decimal value, it is 2700. So when you get this itself, you know that option number B is out. It is not equivalent, right? Okay. And then they have given an octal value. So what you have to do? Convert this into octal. Now to convert from binary to octal, what should you do? You should split the binary into groups of how many bits? Groups of 3 bits, and you should start from your right hand side. Okay. So when you are, let me just do that. Sure. So if on this, you have to like keep on grouping it, groups of 3 bits. Okay. So when you do that, you'll get the decimal value 6, right? 6, sorry, 6. This is 1. This is 2, right? And this is 5. All right. So when you do like this, option number A is correct. Okay, this is wrong. So I converted into decimal at beginning itself, just because I saw they have given it, they have given a decimal value. Okay. Then to convert to hexadecimal, to convert from binary to hexadecimal, you should split it into groups of 4 bits. If it is octal, 3 bits, right? Here from 4 bits, right? So let me just erase that. Okay. So I'm going to divide into 4 now. I divide into 4 here, right? Then this one is what value? 14, right? 14, how do you represent in hexadecimal? You represent it as, right? Let me know that. This is 8, okay? And this is 10. So you know from 10, you represent hexadecimal as A, right? 10, you represent it as A. 14 is E, right? So the answer would be A, 8E. See the option? Yes, it has. So that is correct. All right. Clear? Remember, if it is binary to hexadecimal or binary to octal, we have to group it into 3 or 4 bits. If it is hexa, 4. If it is octal, 3 bits. Okay. So the answer is option number 4. I'll delete that. Okay, and then they are giving what to perform AND operation between these values. So you have two ways. What you can either convert these into decimal and do the AND operation. If not, this. That's a long way. Let's do it this itself. Doing it over here. Oh, is 1 0 1 0 0 0 1 0, right? B is 0. How do you perform AND operation? What is the thing in that? Performing a bitwise AND operation. Both the inputs should be true. Means both inputs should be 1 to get the output 1. If not, it is 0. So over here, it is 0. Right? Here 1 plus 1 is 1. Okay, sorry. I have to go this way, no? You have to go from your right hand side. This is 0, 0, 0, 0. So I'm just doing it directly. If you don't understand, you can let me know that. Over here it is 1, 1, and 1 is 1. Over here it is 0. Yeah. Okay. Was that clear? You have to perform AND operation. AND operation means both the inputs should be true. Yes. If both the output is 1. Miss, I had a connection error. Oh, okay. You can get the recordings and watch the others. Right? Here. So let's see in the option if this is there. Yes. Option number 5. Oops. Clear, no? So remember, if they're saying to perform bitwise AND operation, both should be right. Sorry. So both the input should be 1 for the output become 1. So, right? Otherwise, it is 0. All right. Just keep that in this. I just keep that over here. So if you are going through this PDF, you can see that. Right. Okay. What else? And then they are saying to perform 2's complement. How do you perform 2's complement? I'll just type and show that. So first you have to convert those numbers into binary. So 14, since it is already a positive number, you just get the binary of it directly. But if it's a negative number, what should you do? If it is a negative number, what should you do? So it's minus 22 they have given. Right? So if it's minus 22, you have to flip the bits and only then add them. Okay? If it is a negative number, remember you have to flip the bits. That is known as ones complement, inverting it, flipping ones, turning zeros to 1, 1 to zeros. And then you have to add 1. So that is 2's complement. So for this, what should I do? I should get the the binary of 22 and then flip the bits. That value only I should add. Binary of 22 is 0, 1, 0, 1, 1, 0. Yes. So you have to flip the bits, which is known as ones complement. And you do this only for a negative number. If it is a positive number, leave it as it is. Okay. Yes. So that is ones complement, flipping the bits. Okay. Then what do you have to do? What do you have to do next? Let's see. If you guys remember, two's complement. Maybe some might have not even touched this chapter, no? Came at the very end. Do you first add this together and then add one? Or do you directly add one? You have to first what? You have to do it first. So you have to go in a reverse way and just go from, right way. But I'm typing from left, okay? Since I already know the answer, let me go this way itself. If not, you guys will get confused. So I asked what to do. You have to add one at the what? What is that? You call it as the LSB, right? Yes? Yes or no? Yes, no? Forgot. So it is 1 plus 1 is what? 2, no? How do you write binary 2? Like this. So you just put 0 over here, carry the 1 next side, and then the remaining is same because you don't have anything to add. So I'm getting the answer like this. I'll write it like this itself. It's getting confusing for me now. 0, 0, 0, 8. Lagging a bit. Sorry, wait. Clear? That is that. I will first try the negative positive over here. That is easy now then for you guys. So if it's a positive number, you just get the binary and leave it as it is. But if it's a negative number, get the binary of it, flip the bits, which is known as ones complement, and then you add 1 to the LSB, that is known as what? Two's complement. Okay? Let me just remove that. So it is 0, 0, 0. Okay, I hope this was clear then. So they are saying respectively. So then it is option number 5. Wait, sorry. Where did I see? I missed up that bit. Okay. Clear, no? If it's a positive number, leave it have. It is. Just get the binary, leave it have. It is. Wait a second. My laptop is lagging. Okay. Now it's okay. Just got stuck. Okay, so I hope that was clear. Okay. And then, how many of you don't like hate Boolean laws? Is there anyone? So Boolean laws are some. It is a question. This I would say a topic where most students they don't like it at all. Okay. So the thing is, doing this in this board, I hope I will do that properly in this board. Mhm. Okay, so the first thing if there is a big bar, right? This bar, what you have to do? Let me get the pen. If there's a big bar, right? Relevant to that is what operator? This, right? The OR operator. So if that is so, what you should do? You should remove this bar, break it into what smaller bar, and then change the relevant operator. So this one will turn into plus. This one would be pro. Okay. Just me. Yes, I'll go a bit slow on this because sometimes could mess up a bit. So what you have to do, if there's a big bar, you have to apply De Morgan's law. What is that? Breaking the bigger bar, changing the operator relevant to it. So inside you don't do, inside you do next. It is C, and then since I'm changing the operator, I'm adding plus. All right. Was that clear? This is what law? De Morgan's law. Okay, so I'm representing bar in this way. This is how you represent a bar when you are writing. Okay. For this entire bar also, you will have, sorry, for this entire, this expression, you will have to put a bar. Since De Morgan's law is what you're breaking it into smaller bars. So this one, this whole set will get a bar, and this one will get another bar. So it is like what? Double complement, right? Yes. So next step is then you're applying De Morgan's law for this. Okay. So if you're confused, I will draw that with the pen and show. You have to apply De Morgan's law for this. Since this whole expression has a bar, you have to then break that also and then change its operator. So then it would be like A dot, or you can just write it as C instead of dot. I put dot for reference. Then what will happen? This 8 already has a bar. It will get another bar. So that is going to be double. This C will get a bar. Clear? Yes? Okay. So it's plus. Then this one I'm not going to change that in this step. It's still in double complement. Okay. So when you simplify this one further, since both this is having double bar and this is having one bar. So you know that double bar, if A is having double bar, that is equal to what? It is equal to A itself. Yes. When you simplify it, yes, right? It is equal to A itself. So you're just putting A. And since C bar, we just leave it as C bar itself. Clear? This one, if you're simplifying it, how would you simplify? So you can first just write that as it is and do it in the next step, but I'm doing it over here. So A bar, both, it is having double. See over here, it is having double bar. So double bar is equal to what? AB itself. So no need brackets. I'm removing the brackets. Okay, I'm removing the brackets. I'll remove the dot also. Clear? Was that clear? This step. So you can then, what you can do, you can factorize it. What is factorizing? Taking out the common term. What is the common term over here? It is A. And then you put B inside and then the operator and then C bar is still there, right? Don't forget the bar. Okay? Clear? Clear, right? So the answer is option number 1. Oh, wait. Is that clear or do you want me to like draw the bars and show? I hope you understood the bars. This is having double bar, this is having double bar. Just did it in a typing way. Right. Okay, I will put that. Oh, sorry. Move that away. Okay, yes, right. Wait a minute. I'm putting this. I write the answer. So you guys can now, in case you don't understand the method, you can refer to this once again. Okay, great. So then it is about K maps. Another important topic, right? They could test is in which in your essay part as well, right? Mm. So they are saying which of the following Boolean expression is represented by the K map given above. Okay, so let's see. And draw it like this. I took out the vanishing pen. So see the first column. A, B, okay, so that is 0, and then C, that means what? So this one you show it as, sorry. This one is as C bar. Oh, sorry. I said that as C bar. Okay, just until I do this, can you get the answer of this? Let's see. Who knows? Remember, how will you map? You should map the ones, right? You have to map the ones. So this one, you know, you can map it like this. So then it is being what? 4 cells are being mapped, right? And AB00 means that. So the thing is, the laptop is wait, lagging a bit. Okay, so when you're grouping it into 4 cells, what is changing and what is not changing? A, see A. A is changing to 1, B is changing to, so B is not changing, right? So which one is being consistent? Only B. It is remaining as 0 itself. So what you do? You will take B out. Yes. And that is your what? It should be B bar, no, but answer. Wait. I think the option says, are you guys getting this answer? So it is, I'm taking B out since it is not, it is being consistent. What is the answer you guys are getting? Right? Then you're taking C. Yeah, B bar. Okay. What's the option you're getting? I mean. And then you're grouping. What's the second part? You're grouping. Option 1, right? Yes, 1. So you can group it like this. C is equal to 1. So you're taking what? You're taking C out since it is the same, right? And then which is being consistent over here. A is not changing, right? When you can you see that? Wait, let me just, so you can explain this in different ways. That's what I'm thinking. Like, how would you guys understand it? So just see over here. When you're grouping you're grouping these two columns, right? Which one is being consistent? A. So you're taking A out as well, right? And then C, it's only that one is being grouped. This is not being grouped. So it would be, you're taking C as it is. And not a bar because it is being 1. It is 1. So answer is option number 1. Yes. Was that clear? Yes. Did you get it? When you're grouping, see the one which is being consistent and take it out. All right. Let me just trace this off. Okay. Okay, then the next question will go a bit faster. We still have one calculation. So only calculations I took time because no matter how fast you go, no use. So 13, if we convert it into binary, how much would it be? 1101. And then 125 in decimal form, it is in 2 to the power minus what? 2 to the power minus what? That is correct. No need to. Okay. It is in 2 to the power minus 3, and you know 2 to the power minus 3 is what? 0.125, right? So the answer is getting that itself. No need to explain that. I hope you know binary conversion already, right? Okay, then which of the following statements about 2's complement is or are true? All positive and negative numbers starts at 0 and 1 respectively. True or false? It is true. In 2's complement, the most significant bit is 0, the positive numbers, and 1, sorry, for positive numbers, and 1 for negative numbers. Okay, so that's true. Subtraction is performed by addition. Yes, subtraction A minus B and all. You attend, so there's a question like, I don't remember which year. So subtraction you perform like addition only, right? And then widely used in arithmetic logical unit, S2's complement is the standard system used by the digital ALUs to represent signed integers. So answer is option number 5. Remember that subtraction is performed by addition in 2's complement. So, alright, so there's another one. So when you simplify this, you put distributive law, you will get it as PQ. Can you get this answer out? So I'll just quickly type that and show. We use distributive law to be P plus Q Q bar what are you doing over here? Distributive law, right? Sorry, Q should be coming over here. Q bar. And then you put P plus Q bar R. Alright. Typing this is, I'm doing a bit slow because I have to don't mess up with the bars. Then you get R, then inside P, P is it a bar? No. Clear? See? Let me put a space, then you will understand it. Okay. So P, you don't put a bar in this instance. Yeah, what? You're using distributive law and then you expand it. So when you expand it, you'll get like this. P plus P Q bar R, right? I hope you're understanding it. Then Q P. And then what would you use? You will use factorizing. So when you are using factorizing, it would be like P dot P and then 1 plus QR plus P. So however you're getting the answer, option number C. So I will do that and show quickly. That's 1. So this one I can't go in depth now, but if you didn't understand, you can drop me a message and get it cleared out. Do it with me. Do it. See if you're getting same way. So I'm performing what? Factorize. 1. Then you put plus Q bar R and then yes, that's it. I have done it. So P and P, you know, it's equal to P itself. So 1 you put it at and Q bar R is equal to Q bar R. Right? So this also further it is like this. Q bar. Alright. Yes, did you get the answer C? Okay. So we'll go a bit fast on this. So I allocated 2 hours for this. We can do it, no problem. Okay, so question number 16, right? Which of the following is considered to be the waiting time in the operating system, right? So in CPU scheduling, we use different types of algorithms to measure the not algorithms. I mean like things to measure the system performance, right? So what means waiting time? The amount of time a process spends sitting in the ready queue waiting to get to the CPU, waiting to get the CPU. Okay. So it does not include the execution time or the time spent for waiting for input output events, right? Simply the amount of time a process spends in sitting in the ready queue waiting to get to the CPU, right? Now, what about turnaround time? The total time from the moment a process is submitted to the moment it completely finishes. So, turnaround time is equal to the execution time plus waiting time, right? And response time, the time from process submission until the very first response or CPU allocation is produced. So option number 1, total time of blocked and waiting queues. This is wrong. The time spent in the blocked or waiting queue is classified as input output waiting time, not CPU scheduler waiting time, right? Okay. Then option number 2, that is what I said, the answer, total time spent in the ready queue. Okay. So option number 3, it is saying the total time spent in a running queue, it is false. This is called as the what? The burst time or the execution time. Okay. So option 4, total time from submission to completion of a process. This is known as what? I said the turnaround time from submission to the completion of a process. Total time spent on computer boot up. This is a system boot time. So this is system boot time. This is not related to the individual process waiting time. Okay. So I hope that was clear. Okay. And then a process executed by a computer is called a program executed by a process is called again I missed it up. Okay, sorry. Okay, I sometimes jump on this process and program words. Okay, a program which is executed by a computer is called as a process, right? So, which of the following is a normal state of transitions of such a process? So, an operating system manages process by moving them through a well-defined state system, 7 state transition, right? Okay, so the answer you might have got is the first option itself, right? So I knew what is happening. The process is being created. Example, you're loading the program from hard disk into memory, right? In ready state, the process is fully loaded into main memory and is waiting for the CPU scheduler to pick it. Running state, what is happening? You're actively executing the process instructions. Terminated means the process finishes its work and releases all allocated system resource. So the answer is option number 1. But let's see other options as well, because obviously this is how you do a paper. You don't just go and mark the correct answer and move on. You check why the other ones are wrong. Of course, next you don't know if you get another paper related to that. So option number 2, new block terminated, a newly created process. It cannot jump directly straight to a block which is input out or wait state without running first, right? So that is wrong. Then option number 3, 4, and 5, you can see while states can loop back into running to ready during a timeout or running to block during an input output request. The question is asking what? This question is specifically asking for a normal direct state sequence of a process from start to finish. So that's why they have bolded that. Can you see why? So that's why they say to be careful. See the bolded words. So they're asking a normal state of transition. Even though the states can loop back from ready to running during a timeout, from running to block during an input-output request, they're asking for a normal state. So likewise, the answer is option number 1. So be careful with the question. Okay. And then the operating system uses various ways to make allocation for files. You know that there are 3 types of file allocation methods. It is linked, contiguous, and indexed, right? Okay. So let's see. Among them, Dash creates a table of pointers at the time the file is created. So which of the following is suitable for filling the blanks? So operating system uses different allocation methods to store files on physical disk. Okay. So methods like contiguous allocation, they have what? External fragmentation. And then linked allocation, they have slow random access because you have to read every block to find a specific pointer. So for that, the solution is like index allocation. Why? Because this method solves both issues by gathering all the physical disk block pointers into a single dedicated block, which is called as what? The index block. So when a file is created, this index block acts as a centralized table of pointers. Clear? So this one allows what? Direct, fast, random access to any part of the file without dealing with external disk fragmentation. So the answer is option number 4, indexed allocation. Sorry. Because when a file is created, this index block acts as a centralized table of pointers. All right. What about linked allocation? The pointers are scattered across individual data blocks. And each block, what would have, so the pointers are scattered across the individual data blocks, right? In each block, they contain a pointer to the next block, not in a single centralized table. They are over here they are asking table of pointers. They are mentioning that, right? At the time the file is created. So that is linked allocation. Those are scattered and it points to the next block. And then memory allocation means this refers to RAM management, like not file systems or anything. Contiguous allocation, it is the allocation is done in a continuous, unbroken chain of physical chains. So for this, there is no pointer table created. Sorry. Can't. I just saw the last word and all right. Okay, so an operating system dash is a memory management technique that stores and retrieves data from secondary storage in blocks of the same files, so in the same size for use in main memory. Which of the following is suitable to fill in the blank? So in operating system, they are saying that there is a memory management technique. What does it do? It stores and retrieves data from secondary storage in blocks of the same size. So the answer you might know is simple. Paging, right? To load programs into memory without requiring them to sit in one giant block. The modern operating systems divide memory into fixed size units, right? So the secondary memory, they divide it into fixed size blocks, which are called as what? So they are saying a fixed same size blocks of the same size. They are saying the secondary memory, the disk, they divide it is divided into fixed size blocks, which is called as what? Pages. And then main memory, which is RAM, for use in main memory, they are saying RAM. It is divided into physical blocks of the exact same size called frames, right? Because the blocks are identically sized, the operating system can map any page to any available physical frame using a page table. So this one is eliminating what? The external memory fragmentation. So the answer, it is paging. Paging only stores and retrieves data from secondary storage disk in the blocks of the same size for the use in main memory. Fixed size blocks, which is known as pages. In main memory, we call it as frames. Right? So the mapping happens using the page table. All right. Okay. What is swapping then? Moving an entire process out of main memory into secondary memory. Why? To free up RAM. So this is not dealing with the fixed block segmentation, right? Scheduling is deciding what process gets access to the CPU next. Processing is simply, executing instructions. Context switching is the mechanism of saving the state of an active process and restoring the state of another process so that execution can switch between them. So this is an important topic. Focus on that. Okay, so we have another 21 MCQs more. I'll go a bit faster now since we are done, I think, with the calculation part. So what is a page table in an operating system? It is a component of ALU found in CPU. We know it is false, right? And it is a data structure that stores the pages found in main memory. Yes? Yes or no? Yes? Oh, wait. I didn't send this link. Is the meeting not being live streamed? A minute. Okay. So if there's anyone in that, any doubts, you can let me know. Who is this S. U? Please rename with your full name, your name, your actual name. This is X. Yes, S. U. What kind of name are you joining in with? Okay. Right. Okay. So page table in operating system. This is the virtual memory management, right? Okay. You want me to explain this? No, right? So it is a data structure that maps the virtual address of the process pages to the physical address. So now you know your computer run many programs simultaneously, and each program acts as it has exclusive access to a contiguous block of memory. That space is called as virtual memory, right? So the actual RAM is fragmented and shared among all running programs. To bridge this gap, the operating system divides the virtual memory into fixed size, which I said earlier, it's called as pages, and the physical RAM into chunks called frames, right? So the page table is the map kept by the kernel for each process. So when a program requests data at virtual page number 5, the CPU looks at the page table to find out that page 5 is currently sitting in physical hardware frame number 102. Likewise, right? That was an example. So others, what is it? Another first fourth one, it is a hardware component found in all memories. No, right? So it is a generic hardware chip, and then another name for RAM. No, so it is a synonym for RAM, not another. So it's not a synonym for RAM. Okay, so be careful. It is a data structure that maps the virtual address of the process page to the physical address. So that was okay. Then they are talking about next question. Which of the following information is not generally available in the PCB of an operating system? So you know what is a PCB? It is a detailed data structure created by the operating system for every single active program, which is called as a process, right? So when the CPU switches away from a program to work on another one, it saves exactly what that program was doing into its PCB, so it can resume later without losing progress. So then it records some information, right? Like the process number, which is it is tracking ID, process state, if it is running, waiting, or blocked, right? And then the scheduling state, the priority level, right? And the program counter, the exact line of code that is currently executing. So which one it doesn't have? It's very clear. Capacity of hard disk, right? So this information is generally not in that. The capacity of a hard disk is a static global hardware data managed by the file system and device drivers. So a specific process does not own or track the hard disk capacity inside its individual control block. They are asking which is not available. Sorry, that is there. So process number is there to find it, and process scheduling state to know if it is running, waiting, or blocked. Likewise, program counter. Like, okay. Then consider the following statements about fiber optic cables, right? So this is coming under what? Guided transmission media. Okay, so it has very low annotation. So what means annotation? It means it is signal degradation over distance. So the signal you lose over cause of distance, right? So the copper cables, they suffer high resistance, meaning signals they fade after a few meters, few hundred meters, and they need repeaters. So fiber optic cables, they use total internal reflection to bounce light through pure glass fibers, right? So that is true. Okay, it has. Then it transfers data, sorry, its data transfer rate is higher than other copper cables. Yes, it has high data rates. So light waves operate at, millions of times higher than electrical radio frequencies, right? So that is true. And then it has higher immunity to electromagnetic interference. So electromagnetic interference occurs when nearby electrical items or lightning disrupt the electrical currents inside the copper wires. Because fiber optics, they transmit pulses of light rather than electrons, magnetic fields have zero physical effect on the signal. So yes, it has higher immunity to electronic and clear. Okay. So the next one, which is the following is so correct. Okay. So MAC addresses consist of 6 bytes length. So the MAC address, where is it in? It is in the data link layer, right, of the OSI model. Right. So a MAC address is permanently in the NIC, right? A minute, 1 minute. So just say true or false. MAC addresses consist of 6 bytes length. Yes or no? This is a different kind of question. Maybe you have came across. So what is a MAC address? Media access control. It is a hardware identification number unique to each network interface card. It consists of how many bits? 48 bits. Now, since 8 bits is equal to 1 byte, right? So, 48 divided by 8 is equal to 6 bytes. Clear? It consists of 48 bits and 8 bits is equal to 1 byte. You divide 48 bits by 8, you will get 6 bytes. Clear? Yes? So yes, that is true. 6 bytes of length. And then statement B is saying, this is an example of an MAC address. This is true. So you know these are standardly written, MAC addresses are standardly written as 6 pair of hexadecimal digits which are separated by hyphens, colons also. Right? So this is correct. And then statement C, a MAC address. So the first half of the MAC address contains the NIC manufacturer's identification number, while the second half represents the serial number assigned to the NIC by the manufacturer. So a MAC address is strictly divided into two halves. The first 24 bits, the 3 bytes, are the manufacturer's identification number. Okay. So that is assigned to the manufacturer. Okay. The second 24 bits are assigned by the manufacturer as a unique extension identifier, that is known as the serial number for the specific device. Okay. So I don't know if you might have not studied about this right before. Yes or no? Have you done like these questions? So, however, all are true. Have you ever tried out? So from this session, you might get new things. There are different type of questions. Okay. So, which of the following layer consists of two sublayers in an OSI network reference model? So this is very easy. The open systems interconnection model, it has 7 layers, while most layers operate as one. The data link layer splits into what? Two separate sublayers to manage hardware access and data streaming smoothly. One is known as data link layer divided into two, that is known as logical link control, and another is media access control. So logical link control, what does it do? It manages the flow control, error checking, and identify which network layer protocol is being used for the frame. Whereas the media access control manages hardware addressing, that is MAC addresses, and then it dictates how devices on the network gain access to the physical transmission media. So the answer is 3. It is only layer which has sub layers. So this is also another important topic. They have tested that. Okay, I'm not going to go into the other layers. Okay. So which is the correct, what is the correct order of data encapsulation in computer network? So what is data encapsulation? It refers to how data changes changes form, right, as it moves down or up the network stack. That is the OSI TCP IP model, right? So for this test, my quick short note poster, I think you might have seen if so. Right. So when you check option number 3 only accurately shows the order. How bit is what? The raw physical signals transmitter over cables or wireless media at what layer? At the physical layer, right? And then frame is the data encapsulated with physical MAC addresses at the data link layer. Packet is with logical IP addressing at what layer? Network layer. So remember, bit is physical layer, frame data link layer, packet is network layer, and segment is transport layer. The data is managed by ports and connection states, the TCP UDP at the transport layer. And then data, it is the actual message handled at what layer? The application, the presentation, and session layer. So remember this a bit. Remember this clearly. Frame is in data link layer, packet in network layer, segment in transport layer, data in application presentation and session layer, bit in physical layer. Okay. Okay, so now we are on to unit IP addressing. Okay. Consider the following IP address. How many bits are required to identify the network and the host respectively? Simply asking the number of host bits and the network bits. So can you figure this out? It's very easy. You can get the answer directly, respectively. They are given the CIDR notation 29. Yes. So that CIDR notation 29 is representing what? The network bits. Simple. So see, half answer is there. So 29 is there. Then the host bit is what? So this IP address is using what? Classless interdomain routing, CIDR notation. The number following the slash 29, the first 29 bits are allocated for the network prefix, right? So that's known as the network bits. And the host bits, now you know that every standard IPv4 address is exactly how many bits long? 32 bits long. To find the remaining bits available for identify individual host, you have to deduct the number of network bits from the total bits. How much is the total bits? 32. Network bits, you know it is 29. So 32 minus 29 is 3 bits. So the answer is option number 1. Clear? This is very easy. Okay. Okay, so then they're given some characteristics and they ask you which of these are of TCPs. Okay. All right. So A, reliable. So yes, you have the TCP guarantees delivery by requiring acknowledgements for every packet sent. So if a packet is lost, it is automatically resent. So that is correct. And then B, that is connection oriented. That is also correct. Before any data flows, the TCP establishes a connection between the endpoints using a formal process. You know, the three-way handshake, right? So that is true. And then C is unordered messages. No, this is wrong. So TCP guarantees order messages, meaning it numbers packets so they can be reassembled in the current sequence, not unordered, right? And because it tracks connections, handle errors, and enforces order, TCP requires a complex header. So it creates high overhead. Over here, they are saying less overhead. That is false. So it has high overhead, unlike the UDP layer, which has less overhead. So the answer is option number 1, A and B only. Clear? This is also another important topic. They have tested often, and encryption also is another important topic. Which is next. So which of the following is correct about data encryption? It is the process by which each party each party correctly identifies the parties involved in the communication. Okay, this is true or false? It is false because it is not the process where we identify the parties involved in the communication, right? Okay, and then in secret key encryption, two different keys are used to encrypt and decrypt the data. This is true or false? It is. That is false. It is incorrect. Why? Because this is Secret key encryption is another name for symmetric encryption. In a symmetric setup, exactly one single shared secret key is used for what? For both encrypting and decrypting the information. So using two different keys is the definition. So it's characteristics of what? Public key encryption, which is as an asymmetric key encryption. That is false. Okay, then in public key, each public party is provided with a unique set of keys to encrypt data. This is false. So this is saying that keys are distributed to a public party. So that is false, right? We don't involve each public party, right? In public key encryption. Yes. So each user in an asymmetric network, they have individual, own pairs, one public key and private key. Okay. So a single public key cannot function on its own. Then fourth one, public key is more practical than public key encryption. This is wrong because private key encryption is highly efficient and faster, making it practical for bulk data encryptions like files and hard disks. Right? So if two strangers on the internet want to communicate securely, they have no practical way to safely share a single secret key without someone intercepting it. Whereas public key asymmetric cryptography perfectly solves the bottleneck thing. Right? So it is not more practical than public key. Okay. So fifth one is the answer. The reverse usage of the keys of public key encryption enables digital signatures. It is true or false? That is true. So you know that public asymmetric, it is relying on pair of two keys, public key and private key. So normally someone encrypts data with your public key so that only your private key can decrypt it. So this one ensures what? Confidentially. And digital signatures, they reverse this process. The sender encrypts a document using their own private key. Because the keys are paired, anyone can use the sender's widely available public key to decrypt it. If that right? Clear? So that is it does the reverse usage of the keys of public key. Alright. So that was a bit in-depth explanation. Okay, which of the following can be changed using the frequency modulation technology? This is very easy. What is it? You know, it is option number 5. Yes. So in frequency modulation, the frequency of the carrier wave is varied in proportion to the message signal. So because frequency and phase are like related, so frequency is the time rate of change of what phase, right? So changing the frequency also causes a change in the phase of the signal as well. The amplitude it remains consistent in frequency modulation technology. Okay, so the phase indirectly gets changed. All right. Okay, so which of the following statements about computer malware is so are correct? A computer virus replicates itself and spreads from one computer to another. It is true. Yes, it spreads itself, right? So it is a type of malware that attaches itself to a program or a file and then replicates itself to spread from one host to the another. Okay, then option number B, a Trojan horse. It appears useful to the user before it is installed on the computer, but steals useful information after it is informed. Yes. So it always discusses itself as a useful software to trick users into installing it after which it carries out its malicious activities like stealing data and all, right? So that is true. And then a computer worm it replicates itself and uses a computer network to spread from one to another without user interference. So unlike viruses, computer worms are standalone software that do not require a host program or human intervention to replicate or spread across networks. So remember the difference between those two. Right. Clear. This is easy now. Okay, so we have another 10 more to go. All right. Okay, so DHCP server in an IP network dynamically allocates IP addresses to network devices. It is true, right? So that's the main user use of DHCP server, right? Allocating IP addresses to network devices dynamically. And then statement B, DNS server translates domain names to IP addresses. That is also true. It translates human readable domain names into IP addresses, right? And then C, FTP server caches the recently accessed web pages. This is false. FTP, what does it do? It transfers files, right? Only the proxy server only cache web pages, right? The answer is option number 2. You don't. Do you want me to explain anything in this in depth? Any of the servers? So we are done with unit number. Clear. Okay, great. We are done with unit 6. Now we are moving on to unit 7, right? So I think yeah, we went a bit extra out of time. I hope that's okay. With the calculation questions, I went a bit long, no? Okay. Right. So you know that there are different types of models. So they are saying to consider the following table consists of software process models and explaining them just to match the definition. Let's first go with this column V, Y. So it is more focused for a system with requirements that have risk of changing. Okay, so which model do we use when your risk is high? We use The spiral model. Remember the risk analysis and all. So it heavily focuses on the risk analysis, right? So it splits project developments into repeated loops, spirals, right? Okay. It is suitable for a project with new business engaged with stable requirements. So this is very easy. If they are saying stable requirements, then what it is? Right. Right. So you're confused if it is waterfall model. That is actually related to RAD model. If you're confused, go to the next one. Right. The initial version of software was developed, tested, refined as per user feedback repeatedly till a final acceptable software is achieved. This is very easy. It is about prototyping model. So prototyping focuses on building an early trial version, which is known as prototype of the system, right? So this is then handed over to the client for evaluation, and based on their feedback, the model is refined continuously until the client approves the foundation. Okay. So it is then D, it is characterized by a set of clearly defined milestones and deliverables. So this is very easy. It is about the waterfall model. It is a linear sequential development life cycle. So each phase, which is what is the phase? Requirements, design, implementation, testing, maintenance. They must be completed before the next. So the process flow, so the flows strictly downwards, and each phase finishes with a milestone. Right. So that is waterfall model. So yeah, however, B is radial rapid application development model. Then E, it refers to a software development approach based on iterative development, and this method breaks tasks into smaller iterative with time slices. So remember, whenever they mention time slices, it is about agile. So agile strictly breaks down breaks project workforce down into highly dynamical blocks, right? So it's divided into timely slices. Okay. So the answer is then set option 1B 22. Option number 4, right? So 4 it is E, no? Yes. 4 is E, 5 is B. So it's option number 4, right? Clear? Okay, which of the following provides the best option for meeting a specific set of requirements for a scalable and secure information system? Okay, using of open source software, is it best for meeting a specific set of requirement? No. It provides the what? Building block. Okay, let's see. Developing of custom software. So yes, that is the answer itself. So if your requirements are specific, then the best option is what? A custom software, right? Purchasing of commercial off-the-shelf software. It is what? It is a pre-designed structure. It has pre-designed structure, not specific. You cannot customize it according to you. Okay, copying from a friend, that is not relevant to this. Obtaining softwares from service providers. No. Right. So the best option for meeting a specific set of requirements is a custom software. Easy, no? Okay, then we are coming on the testing part. They ask you the correct order of software testing. Right? Right. So let's see. Determining of expected results. No. So no, that's not coming first. Right. Expected results. Then comparing of actual output with expected result. This one is coming at the end, right? Then determining the functionality to be tested. So yes, that is the first step. You're determining the functionality which you want to test. Then after you determining of the expected results. Sorry. Yeah, correct. Okay. What you're doing, you're determining the functionality to be tested, and then you're determining the expected results, and then you're conducting the test. After that only you're comparing the output with the expected results, right? So if you determine the expected results first and then conduct the test, after that only you will compare it. So when you do that, this option will be 3. Is that clear? Yes? You determine the functionality which you want to test. After that, you're determining, okay, what expected results. And after that, you're conducting a test and then you're comparing it with your expected results. Okay. And then 30. Okay, so this is also still unit 7. So see how many MCQs, even in your final paper also they test lot of MCQs in unit 7. They test these systems, right? So you know that there are different types of information systems, executive, decisional expert, right? So they are saying to match with the description. A system which uses knowledge to solve complicated problems in a logical manner. Very easy. This is what? The expert system. These systems use the human knowledge to solve problems logically, right? That is A. And then as information system that compiles data and analysis models or provides the administrative staff with analysis tools, makes the semi-structured and structured decisions of an organization. So which one provides semi-structured and structured decision? That is the decision support system. These systems only compile data and analysis model to help the staff. Okay. So always remember it provides semi-structured and structured decision. Then information system that addresses unstructured decision making through advanced graphic and communications for strategic level are executive support system. That is very easy. These systems, they have unstructured and they are used for top level uses. So when you match it, the answer is option number 5. Okay, and then deployment, you know that there are pilot, parallel, phase deployments, right? So they're saying which of, okay, they're saying about system. Let's see. A small group of users within a user using a new system before wider use is a pilot deployment. A small group of users is using a new system before we use it for others. This is true. And pilot first you use for a small area and then move on to the next, right? Okay, then parallel deployment is an implementation in which small parts of the new system gradually replace small parts of the old system. This is false. This is what? Then this is phase deployment. Parallel what happens? It runs both the old and the new system simultaneously. So that is false. Okay, and parallel deployment is more risky as compared to direct deployment. This is false because it is less risky than that because the old system, because in parallel you have your old system as a backup, right? So this is less risky. Okay, whereas in direct you don't have your old system as a backup. So they are saying which of the above is true, sorry, or are false, and that is statement B and C. Okay, then 37. Which of the following may be a functional requirement? So you know there are two types of requirements, functional and non-functional requirement. Functional, what do they define? They define the specific behavior, functions or features of a system features of a system that it must perform, right? Like logging in, calculating or generating reports. So being able to log into the system by registered students is the answer itself. Let's see the other options. Computer user interfaces should be simple to avoid confusion. They're saying about the usability, so it is related to non-functional, right? And the system should be able to handle 100 students per second. That is about the performance and all. It is non-functional. So non-function is about the usability, the performance, the accuracy, reliability, and all. So system should be available 24/7 is also non-functional. And the accuracy is about non-functional. I said it should be accurate enough. So remember functional is about what? It defines a specific behavior, function or features a system must perform, right? Okay. So then you know that there's something called DFT diagram. So they are asking about the external entities. They have tested this a lot. They have seen in other papers also. So an external entity can be a person, a system, or organization that has predefined behavior through they are outside the system boundaries. So their internal behavior is predefined or independent of the system, right? External or outside, right? So this is true. And they can be a source of input data for a process or and a destination of the output of a process. So external entities, they can act as a source or a destination, as a provider or a receiver of data as well. This is true, right? Okay, then see, external entities are always data stores. This is false. External entities are not data stores, right? Mm. Right? So data store is like where the system holds the data at rest, like a database table. So the external entities, they do not store data inside the system. Okay. So answer is A and B. Only they are asking the correct one, no? Okay, so still yeah, this is unit 7 is the end of your grade 12 syllabus, right? So 39, user acceptance testing is done by whom? Carried out by software developers? No, it is done by it is the final phase of the software testing process before the software is released actually, right? So that is false. And then carried out by software engineers, that is also false. It is performed by software analysts. No, it's by the word itself, it is carried out by whom? By the end users with the help of software developers. So the goal of this test is to verify if the software handles real world business scenarios and meets the actual need of the people, the end users, right? So who does it? The developers and the analysts already know how their system functions technically. So this user acceptance testing must be done by the actual end user or clients to confirm if it works correctly in a practical business environment. The developers role, the end users are generally not technical experts, right? So therefore the software developers, they stay nearby during this testing to help them set the environment and explain the technical behaviors and log any bugs or issues that the user develops. So that's what they mean by with the help of software developers, since they don't have technical knowledge, right? Okay, so we have come to the last question of the day, of the session. Which of the following is a type of information system that uses database of expert knowledge to provide advice or make decisions in areas such as clinical diagnosis? So they're saying which uses database of expert knowledge to provide advice for, like, example, for a clinical diagnosis. So this is very easy, simple. The name word itself says it, right? Transaction processing system. What does it do? It helps in what? Recording the routine, the day-to-day business activities like payroll and all, right? Executive information system. They help high-level executives monitor organization performance and make long-term strategic decisions. So the answer is third on expert system, right? Well, let's see. Then geographical information system, they analyze and display the data related to physical locations, right? The maps. Management information system, they generate reports from transaction data to help. Who do they help? The middle level managers to oversee the business operations. So answer is option number 3. And you know that in the expert system, right? It is a computer program which is designed to solve complex problems and provide decision-making advice, right, by mimicking the reasoning of a human expert. So it has two types, like two components, the knowledge base and the interference engine. You might have seen the diagram. So knowledge base is the database containing facts like if and then rules, which is provided by these experts. Interference engine is the part of the system that applies the logical rules to the knowledge base to reach a conclusion. The example, like diagnosing a medical condition based on the symptoms. So that is interference engine. These are the components of an expert system. Yes. So we are done with this session. Okay. Yeah. So I know I went a bit I want to do it within 2 hours. I went more than 2 hours. I'm sorry for that if it's so. Okay, I hope my speed was okay and good. I hope I wasn't too fast and I hope you were able to understand everything. Yes. So, how was the session? Did you think, like, were you able to? So, my goal was mainly to make you guys recap your grade 12 syllabus. Is that so? Were you able to all the important components of your greater syllabus? So we studied UDP, TCDP, the types of information system, what the process state and all everything. Yeah, covered almost, right? Yes. So was that useful? Yes, let me know. Do you think that were you able to recall all your grade 12 syllabus, the concepts? Stop this. So for the next session, let's see what I have planned to do. Should we do another session like this? What do you say? I have planned to do like full, Mora papers, like full, including grade 13 chapters, MCQs. So that will take longer than this, right? This no, we're not going to do part two of this paper. It's not that much, really useful. You can try it out. If I have enough of time, I will discuss the part two of this paper. Okay? Yeah. So it